Hi there, welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we'll be discussing all things to do with mixtures for the GCSE chemistry topic. Content covered today includes what are mixtures, filtration, crystallization, simple distillation, fractional distillation, and chromatography. So let's get started. First of all, what actually is a mixture? Well, a mixture is two or more elements or compounds which are not chemically combined together. And if you want to learn more about elements and compounds, please feel free to check out my previous video. I'll leave it in the cards above. The chemical properties of each substance in a mixture are unchanged, and this is because there has been no chemical reaction which has occurred. We've just mixed those substances together. Some real world examples include blood in our veins, which contain different cells like red blood cells, white blood cells, also platelets and plasma. Sand and water at the beach is another example of a mixture, and even in recycling plants where metals, which are magnetic, can be separated from non magnetic materials using a magnet. At GCSE, you need to be aware of different examples of separation techniques, and those separation techniques are chosen depending on the type of mixture in front of you. So, a few other keywords just before we get into those are freezing, condensing, melting, and evaporating. These are all to do with state changes and will be referred to often in this lesson. It's a key stage three bit of knowledge, but let's just recap it anyway so we're all understanding. Solids can become liquids by melting them and adding heat. Liquids can be further heated up to form gases, and this is what we call evaporating. The reverse can occur when a gas goes back to a liquid state, and we call this condensing. And condensing requires a very cold temperature. We can further cool a liquid to a solid, and we call this freezing. The other state change you may have heard of is called sublimation, and this is when a solid becomes a gas and misses that intermediate liquid state, and this is quite a rare state change. So, one of the key examples of a separation technique includes filtration, and this comes across the curriculum quite often. In chemistry, you'll have this in the required practical for making salts, and in biology, you will see this in the food tests required practical. Filtration is used to separate an insoluble solid from a liquid, and it's often used in very simple cases. Maybe you're separating sand from water, or in the case of the required practical, we are removing any excess reactant from a reaction mixture. So, some of the keywords that often get mixed up when talking about filtration is solute, solvent, and solution. So, let's run through those now. A solute is a substance that is dissolved. So, an example of that could be sugars. A solvent is able to dissolve that solute, so it could be water, and the solution is just the mixture of the solute and solvent. So in the case here with the picture, you can see we've got a green liquid, that would be the solvent. The brown circles are the solute, and when we mix them together, we have a solution. Filtration works because the filter paper that's in the funnel have very tiny holes, and they're only large enough to let very small molecules or dissolved ions through. But anything that's larger than that will remain in the funnel and won't pass through. And anything that comes out of the funnel, we call the filtrate, and that often is a pure substance. Crystallization is a similar method that's often used to separate substances. It's used to produce solid crystals from a solution. And what happens is we would get the solution from the beaker, pour it into an evaporating basin, and heat this up. Once crystals start to form around the edge of the evaporating basin, the evaporating basin is pulled away from the Bunsen burner and left to cool. And that cooling process would require about 24 hours to allow the substance to cool down very, very slowly and produce solid crystals. Now, this again will be covered in a future video along with filtration when we do talk about the required practical in chemistry for making salts. Another method of separation of mixtures includes simple distillation, and it's used to separate a solvent from a solution. So you have a liquid in a round bottom flask that also has another liquid inside, perhaps, or something like a solid that has been dissolved. So let's say we're on a desert island and we had salt water all around us. It's not potable. We can't drink that water. It's not safe to drink, and therefore we want to get pure water from it. So we heat up the salt water in the round bottom flask using a Bunsen burner. The liquid will become a gas as it has been heated to a high temperature. What then happens is that gas will be cooled down in a condensing chamber, and that cooled gas we say that it condenses into a liquid. That liquid runs off into a conical flask, and within that conical flask, you will find a pure solution, a pure substance. Fractional distillation is very similar in terms of heating up a liquid to form a gas and then cooling it down back into a liquid. However, fractional distillation is used to separate different liquids from a mixture of liquids. Fractional distillation works because the different liquids actually have different boiling points. So, crude oil is the liquid we are talking about. It is a mixture of hydrocarbons, which basically just means a substance which contains only hydrogen and carbon. But in its raw form, crude oil that comes from the ground, we can't actually use it. So, the way we make it useful is we heat it up, and as it heats up, the different fractions of crude oil, the different substances found within, whether it's petrol, kerosene, petroleum gas, they actually get separated based on their boiling point. So when the mixture is heated, the vapors will rise through the column, which is hot at the bottom and much colder at the top. When those vapors start to condense, they reach a part of the column that is below the temperature of their boiling point. And that essentially allows the liquid to be carried away from the column and separated. And like I say, these liquids include petroleum, gas, or petrol, and they can be used for various important things, such as powering cars or used in like a kitchen setting to power the gas stove. Last but not least, the last method of separation includes paper chromatography, and it is used to separate mixtures of soluble substances. These are often colored substances like food coloring, or maybe it's a type of ink or a pigment, or even some plant pigments like chlorophyll that can be used too. The chromatography method has two stages you need to be aware of. We have the stationary phase, which could be paper. It's a very absorbent, very uniform type of paper. The mobile phase as well is the solvent that moves through the paper, and this carries the different substances with it. And the reason it does that is because the different dissolved substances in a mixture are attracted to the two phases in different proportions, and this causes them to move through the paper at different rates and allow for that separation to be seen. This is very useful in industry if we want to identify certain substances that make up a particular mixture. Like I say, we will cover these topics in a bit more detail as we move through the course. So if you want any further support or help, please feel free to follow me on Instagram at the GCSE Science Teacher, or comment below for any particular topics you'd like me to cover next. In the meantime, I've been the GCSE Science Teacher and you have been curious. Thank you so much for watching, and I will see you next time. Bye.